Hello, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. It is called minimum operations to make binary array elements equal to 1, and that's the first one. So you're given a binary array, so that will be ones and zeros. You can do the following operation any number of times, and possibly 0 times. So you can choose 3 consecutive elements and flip all of them, or you can flipping an element means changing its value from 0 to 1. So that would be the not operator. But yeah, anyways, it's just flipping the bit, of course. So return the minimum number of operations required to make all elements in nums equal to 1. If it is not possible, we want to return -1. Right. So what is our what is our bounds? So we have 10 to the power of 5. Yeah. So we want to flip all the bits to 1, and one observation we can make is every time you flip, it is every time you flip like 3 consecutive elements, you are wait actually let me draw it out. So so the only way to like really get rid of zeros is if we flip like all 3 of them into ones, right? So yeah, so why does this case not work? I'm guessing that maybe it has to be like the number of zeros has to be a multiple of 3 or something. But um hmm actually, is that even true? That's technically not true, right? So cause like what if we have something like this? We can flip this, and then this is gonna work. But another thing I think I can try out is so let's say we have a 0 at the beginning. um well, we want to get rid of it, right? So we can flip that, and then we look at the next 0, we flip that, and then see whether it works. Yeah, so that could be a possibility. But what if there's a case where you have to flip like from the back to front? So that's something that we have to like think about as well. Um, is that true though? So what if we have something like um something like this? Well, that's symmetric. So yeah, actually. So if we flip that, hmm. So if we flip that, yeah, I just want to think about in what circumstance does our array become like not possible to filter anymore. I think it is when you get to when you get to 1 0 or 2 zeros, you can't possibly get rid of them, right? Um, but it doesn't necessarily have to be. Um, wait, actually, if we have 2 0, this is still gonna work. So, because of something like this, and then you turn that. Um, there isn't a very obvious solution here, so we need to think a bit harder. Um, so in this case, we turn it into this. But can we do something else though? Yeah, so every time we flip, um, hmm, 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 hmm. Yeah, I'm still thinking whether there's a counter, because like my idea right now is like just greedily flip until you can't flip anymore, right? Um, but there are cases where maybe you do want to flip. Actually, is that even true? My intuition is telling me that I just I just keep flipping from left to right until I can't do it anymore. Because let's say you already have a one, and then you have like some other stuff at the back. You don't want to flip the first bit again, right? Because if you flip that, um, that means like it will become 0, and then you have to end up flipping that again. So, um, and that's kind of not ideal, right? Unless you have a 0 here. Yeah, actually, what happens if you have like that? So if you flip, then it becomes, well, but actually in this case we can just flip that. Yeah, so maybe doing a full proof is a bit hard, but yeah, I'm pretty sure if you just go from the left, it should work. If I think of how to prove it, I'll try to prove it. But otherwise, I'll just code this out right now first. Yeah. So so we have for we probably shouldn't do for x and nums, right? We'll do for I in range length of nums. So if if nums I is equal to, okay, so it is a list of ints. Yeah, the length, yeah, obviously it is 100k. So if it is 0, if it is 1, we don't want to do anything to it. So yeah, so that means we actually only want to do something where it is 0. We'll just do the flattened way. Yeah. So that means like nums I is 0 right now. So we want to flip. But if we can't flip anymore, so let's say, yeah, so let's say I is like at the end already. We can't flip, like we have to flip 3 consecutive, right? But if it is the last element and we are flipping it at the start, it just wouldn't work. So yeah, so let's flip that way. So wait, what am I saying? We can just do something like if I, oh, but then it has the minimum operations as well. I'm not sure if my approach is minimum. That's an issue. Wait, actually, it should be minimum because, yeah, it should be minimum. But yeah, just using my intuition here. So if I plus 2, so that's the last thing that we want to flip. If it is larger than length of nums, that means it will be, well, out of bounds. We want to return -1, so we couldn't find a solution. We also want the number of operations out here. So number of operations we want to increment by 1, and then we want for j in range I plus 2, I plus 3, because it is exclusive. We just want to do nums j. So we want to XOR with 1 to flip the bits. Yeah, so the reason why this works is because 0 XOR 1 is 1, and 1 XOR 1 is 0, so you can just flip the bit like that. instead of writing out conditional statements. And at the end, we should have all the bits to be 1, so we can just return number of operations out here. I think that should work. Oh no. Okay, so that is -1. Yeah, so I should be flipping these first. So it should be 1 0 0, and then it should be flipping this to be 1 1 0, and then I should see this, and then I should flip that, right? Yeah, why is it returning -1 though? Okay, let me print out the eyes that we are dealing with here. Huh? Oh, just flip this around. Yeah, what I was doing is, if it is smaller, I'm returning -1, but we actually want I plus 2p larger or equal. Yeah, okay, that works. And wow, it's my 69 shriek. Nice. Yeah, I'm actually really interested in the proof. So let's have a look. So that's the overview of the question. Using a DQ, if it appears at the end of near the end of the array, yeah, we cannot flip it using a full triplet. Yeah, that's correct. So it affects 3 elements. Each flip we apply has a lasting effect on the next 2 indices. Yeah, so it kind of has the same idea. So I guess the proof is something like if you do have a 0 like at the beginning, you're forced to flip it, right? So when you flip it, you're going to have more ones at one side, and like you can't skip this step, so that goes to the minimum operation thing. Yeah, you can't like you can't ignore it, because then it wouldn't be like a full array of ones. So you have to flip it, but then let's say we have something like 1 0 1. We don't want to and let's say this is the first 0, right? We don't want to flip the earlier elements, because that means we'll have a earlier 0, and that's kind of not what we want. It's a bit like, I don't know, like the squeezing thing. Like, you know that cake thing when you like try to squeeze out, and you try to like squeeze all the 0 to one side, and I want to see whether you can get rid of it at the end. So yeah, it's something like that. Let's see. Do they have another? Oh, they're also using sliding window. So instead of, I think this is like the way I'm doing. Yeah, at the most efficient way possible. Scan the array from left to right. Yeah, when you focus on the last element of each triplet. So that means we check if, yeah, okay, yeah, that is what we did. So we ensure that every 0 gets handled at the earliest possible opportunity. Yeah, so yeah, I guess that's kind of the idea here. So that's the initial array. So you flip that. Yeah, so like because the earliest is 0, we have to flip that. Yeah, so it's kind of like a greedy, but then it also works. Oh, maybe this is the one. Yeah, it doesn't really talk about the proof though, right? Oh, okay, let's prove the greedy approach. Method of induction. So smallest possible cases. Yeah, so we have that. And then, so that we have, then flip last 3 to, huh? That doesn't work, I think. It is suggesting you can just flip the last 3 to get that, but it doesn't work. But yeah, I guess maybe induction also works. Like, because like just keep cutting like more. yeah, so it's something like when you have a zero at the beginning, you have to flip it, and and after you and you need to spend one operation on this zero, right? And after you flip it, well, you do need to spend an operation here. So I think it's something like that, yeah. That makes it like optimal, and that makes it works. And yeah. Yeah, I guess today's question, it's a bit difficult to prove, but to get to the idea is not too difficult, I think. But yeah, thanks for watching, and if you have any feedback, make sure to comment below, and I'll see you tomorrow. Bye.